And as I had mentioned, when we stopped at this chapter was not included in your midterm exam, but this is a key chapter in the overall understanding of financial management, plus other business discipline areas, because it's important to understand the relative valuation in the present value and future value terms. So what would this difference really explain? If you have too much of difference between the present value and future value, what does that indicate? It indicates several factors, one being a high cost of capital, other being sort of a risky business environment, and overall perception of discounting at a higher rate. Whereas if you have a very marginal difference between the present value and future value, what does that indicate? It will indicate a relatively safer or a more conducive business environment and a less cost of capital for business owners and so forth. So the idea is to try and keep the discount factor to a minimum. That is what the business operators would want. So let's move on in discussing the chapter, and the next part is looking at the uneven cash flows. So what we had done previously was to look at cash flows where they were in terms of annuity or perpetuity, where there was a periodic payment that was of equal value. But there are instances when cash flow is going to be uneven. And this is a basic graphical representation of an uneven cash flow. And we can really use Excel to our advantage to, work this problem out. So let me just quickly copy the numbers onto Excel worksheet, and then I can demonstrate. Remember, these are being discounted at a rate of 10%. So just give me a moment. Okay, so let me share the Excel worksheet. Okay, students online, can you all view the Excel worksheet that I'm sharing? So remember, these uneven cash flows are to be discounted in today's value at the rate of 10%. And so we can use individual present value, calculations for these future cash flows. So remember, the first 100 is just one period away. So this is going to be 100 divided by 1.1 raised to the power 1. So that's 1 plus r raised to the power 1. And that's $90.90 approximately in today's value. Similarly, for 300, you can simply put 300 divided by 1 plus 1, which is 1 plus r. R is 10%, raised to the power 2. That's going to be 247.93. And for the third period, it's going to be 300 divided by 1.1 raised to the power 3. That's 225. And then finally, negative 50 divided by 1.1 raised to the power 4. So that's negative $34. So what we can do is, let me see if I can put a dollar sign here so that that'll be very easy to understand. So this is in future terms, and that's the present value. So this is the future value, and this is the discounted present value. And again, what I'll do is I'll share this Excel sheet once we are done, and you add all these stream of revenues in today's funds, and that'll be $530.09. So I can just name it as that's the uneven cash flow example. All right, everyone clear with this? Let's go back to the PowerPoint. So there you go. We got the same answer as the PowerPoint. It's $530.08. That's the present value. Now, we can also use a calculator to do this uneven cash flow example. I'll demonstrate that in the BA2, Texas Instrument BA2 Plus. So the way you do it is you need to enter the cash flows into the financial calculator. Let me show you how to do that. It may be a tricky thing for the financial calculator. So if you have a calculator, just follow this with me. Can you all view the financial calculator that's displaying now? Students online, can you view the financial calculator? All right. Like anything, first thing to do is just clean out the registers or the memory. Do that by second, reset, enter, and that would clean out any memories in the calculator. So the first thing that we need to do is start inputting, these cash flows. That you can do by pressing the CF button, which is the second button in the second column, the CF. So click on that, and as you can see, it's showing cash flow at time 0. Remember, at time 0, we don't have any cash flow. So you can simply just click this arrow down, and it'll take you to cash flow at period 1. This is $100, so enter 100. And then press enter. So you can see that again the triangle points towards CO1. That means that $100 has been input in the memory for CO1. Now again, press this arrow button down. Now it shows for how many periods. For example, is it for 1 period or 2 periods or 3 periods? Because sometimes you may have same cash flow for multiple periods. That by inputting the value here in FO1 will help you save multiple entries of the cash flows. And I can show you with the 300 example. But in the case of the first one, 100 is only once. So I'll scroll down again. So now the second cash flow is 300. So I'll enter 300 and then press enter, and it enters 300 into CO2. And then again, press arrow down. Now you come to FO2. Now remember, 300 is being paid out at cash flow period number 2 and 3. So to avoid entering 300 again, what I can simply do is press enter. I can just put 2 and then press enter. What that means is 300 is being repeated for 2 cash flow times. And then again, arrow down. For cash flow 3, it's 50, and then negative because it's a minus 50. So you actually are losing funds here, and press enter. And you are done with this one. So what you do is press the net present value, and here the discount factor is 10. So you just enter 10, press enter, and then you would compute. You will again scroll down to NPV and then press compute. So there you get the answer, 530.09. So that's another way to do it. I mean, we did that first one, which was Excel based, and this one is financial calculator based. It is, a longer stepwise calculation, but I'm just showing you it's possible with calculator as well. I can show you another simple way to do it. By the way, it's recorded, so you can always go back and review it, the steps. If you have a financial calculator, then you can review the steps and you could do it again. So let's now look at another simple way to do it, which is, so this is, by using the financial calculator. Now, another simple way to do it is simply by using Excel, again, by entering these values and then calculating by using the net present value function. So let's try and do that as well. And then you'll see, that it's very easy. So can everyone view the Excel again? So let me just put 0, 1, 2, 3, 4, 5. And remember, in the first, in the 0, 1, there's nothing being paid out. The first one is 100, then 300, then 300, and then negative 50. So these are the cash flows. And you want to calculate the present value in today's money. So all you do is do the function call by start typing out with an equal sign and then NPV, which is net present value. And you can see that's already showing returns the net present value of an investment based on a discount rate. Open bracket, rate we know is 10%, and then comma, enter all these values. Okay, and then bracket closed, enter. So again, it's 530.09. So, that is a relatively simple way of calculating net present value. So either of the way is fine. You can calculate by using individual discount rates, calculating like I showed in the first example, or by using financial calculator, or by setting up a table like this and just calculating simple net present value. All right, so is everyone clear with the net present value? Students online, everyone clear with the net present value concept? All right, so now we come to an important aspect of various ways that the interest rate can be stated. The nominal rate is a very simple way of saying, what the rate is as you observe. It's stated in contracts and quoted by banks and brokers. But these are not used in calculations or shown on timelines. Why is nominal rate not shown on timelines or is not calculated? Because remember the aspect of compounding. So the effective rate could be very different from the nominal rate because of the number of time periods that may be involved, and we'll show that with example. So periods per year, M must be given. Examples, 8% quarterly. So 8% is nominal, but once you take into the effect of the quarterly, then your actual or effective rate will change. Why? Because you will have that effect of compounding, which is going to impact your final interest rate that you will pay. Similarly, 8% daily interest is going to be totally different than just 8% annual, or the nominal. So always check the complete representation of interest rate that's been quoted to you, how it's been quoted. So the periodic rate is something that you should, lay emphasis on, because it breaks down your actual nominal rate based on the M. M meaning number of time interest rate is charged over a calendar year. So if it's a quarterly paid rate, that means your nominal rate would be divided by 4. For example, 8% divided by 4. If it's a daily rate, then it will be 8% divided by 365, which is this number here. So you need to be taking into account the number of time you're paying interest, because the factor of a compounding will impact your effective rate. So will the future value of a lump sum be larger or smaller if we compound it more often, holding the stated interest rate constant or the nominal rate constant? Larger. Why? You're compounding more times, obviously. So the more you compound, the factor is going to increase, and that's going to increase the lump sum. So a 8% annual interest rate is not same as 8% monthly rate. They are different. So obviously, as we have identified, the answer is that's larger if compounding is more frequent than once a year. For example, semi-annually, quarterly, or daily, interest is earned on interest more often, and that's the reason why the resulting final number is going to be larger than the nominal rate. So the future value formula for different compounding periods is simply present value multiplied with 1 plus, remember what is the future value formula generally? Present value multiplied with 1 plus r raised to the power t. But now that you have the factor of number of times interest is paid during the year, you got to divide that by m, and then likewise multiply m on the raised to the power. So for example, 100% at 12% nominal rate with semi-annual compounding for 5 years. All right, that's an interesting. Let's take. I'll open up Excel again. So it's saying, let me just make a note of it. Okay, students online, can you all view the Excel worksheet? So this is the example of semi-annual. If, for example, you have 5 years, you put your money away for 5 years and interest is paid semi-annually at 12%, you're putting away $100, what will be the resultant final value or the future value? So this, let's say, is annual. Let's start with annual, then we can do semi-annual, then we can do quarterly, we can do monthly, and we can do daily, just to compare and understand what's going on. So in case of annual, you don't have to do anything because it's just paid once a year. So it'll be future value, rate is 12%, number of time periods is 5, payment is 0, and present value is -100, type is 0. So your future value would be 176.23 after 5 years. What about semi-annual? N would be, in this case, will be 10. Interest rate will be 12% divided by 2, that's 6%. And payment is again 0. present value will keep 100. So future value will be, rate is the 6%, number of time periods is 10, payment is 0, present value is 100 times 0. So it'll be 179.08. So you got additional $3 odd because you are being paid interest semi-annually rather than annually. So you can see that your sum is becoming larger. In case of quarterly, let me just now copy this over. Let me see if I can. So quarterly is going to be, no, quarterly would be 4. So it'll be 40. And this is correct. Okay, yeah. So this would be, let's see. Yeah, now it will be correct. So this is C multiplied by 2, which is now going to be 20. IY is going to be 3%, just to make it clear for everyone. I'll just put it in percentage terms. So payment is still 0. Present value is 100, and you can see that how the rates have changed. The final amount has changed. So obviously, the more times the interest is paid during the year, the larger the number you'll end up with. So what do the credit card companies do? They offer you a annual percentage rate, but how do they charge interest? They charge interest on a daily rate, daily balance. So that's in the fine print. You know, you'll need a large magnifying glass to read it, that interest rate is charged on a daily rate because it benefits them. Yeah. Right. Yes. Yes. You're reinvesting the dividend, and that has a huge impact. And okay, students, can you all hear me? This one is here. All right, so let's move on, and this is the same demo that I just did, so you can see that you can try and work out, in a similar fashion. And we, I think, got the same answers. So the effective annual rate is annual rate that causes present value to grow at the same future value as under multi-period compounding. So this would be the rate that you would end up paying, that in effect you would be paying with that effect of compounding. So an example here is invest $1 for 1 year at 12% semi-annual. You end up with $1 and 0.1236. So the effective rate that you actually receive is going to be 12.36%, this component here, and not the 12%. Why? Because 12% would have been in the case of interest being paid once a year, whereas in semi-annual, because interest is paid on interest received at the 6th month, you end up getting a 12.36% effective return. So the semi-annual compounding would grow to the same value as a dollar invested for 1 year at 12.36% annual compounding. So comparing rates, An investment with monthly payments is different from one with quarterly payments. Must put on effective percentage basis to compare rates of return. Use effect percent only for comparisons. Banks say interest paid daily, same as compounded daily. So I can show you, even in Excel, how you can get your effective rates. Students online, can you all view Excel again? So there's a very simple function in Excel called effect. So you start typing equal to effect, and you can see that's already popped up. I can double click it, and it says the nominal rate, comma, number of the periods. So for example, if I take the case of 10% and comma your number of times compounding, I just put 2 there. So you can see that the effective rate actually is going to be 10.25%. That's the effective rate. And you can check for your car payments also. Normally, if you've been quoted, let's say typical rate would be 3.99%. So you can just put effect. The good thing about Excel is once you have a worksheet made, you simply have to put numbers and it will automatically update for you. So for example, this is 3.99% and that's 12. So your effective rate on a quoted 3.99% is going to be close to 4.06%. That's what you'll end up paying because of the factor of compounding. So this is exactly what we just did in Excel. The answer is 12.36% here. For example, you took effective for a nominal rate of 12%, compounded semi-annually. You can use the formula here by taking the nominal divided by the number of periods. In this case, was 12% divided by 2, raised to the power 2 minus 1, and that brings you to 12.36. Or you simply can use effect in Excel, and you'll get the same answer. So again, just to demonstrate from various aspects, effective annual rate or effect percent for a nominal rate for 12%. Again, it's been done annual, quarterly, monthly, and 365. So I'll let you just try this as a homework assignment to do for 12%, 10%, and 15%. So calculate the effective annual rate for a nominal rate of 10%, 12%, and 15% on annual basis, quarterly basis, monthly basis, and daily basis. And shouldn't take you more than 5 minutes to do it in Excel. So here's a question: can the effective rate ever be equal to the nominal rate? Something that you've been asking. Can effective rate ever be equal to the nominal rate? One period, yes. If it's one period, you pay just once a year, effective rate will be equal to the nominal rate. So the answer is yes, but only if the annual compounding is if m is equal to 1. If m is greater than 1, then always effective rate is going to be greater than the nominal rate. That's a conclusion. So when is each rate used? The nominal rate is written into contracts quoted by banks and brokers, not used in calculations or shown on timeline. Why? We've seen that because it's going to give you a wrong answer. You have to take into account the number of time periods the interest is paid during the year. I-periodic, interest rate periodic, used in calculations and shown on timelines. If nominal rate has annual compounding, then the periodic rate is equal to nominal divided by 1 equals I nominal. That is, if it's only once. That's a special case. When and the compounding is done only once a year, that is, once it's paid, then your periodic rate will be equal to nominal rate, because I norm is divided by 1 is I norm. When is each rate used? Effective rate, used to compare returns on investment with different payments per year. Used for calculations if and only if dealing with annuities where payments don't match interest compounding period. So if, let's say, for example, you had to compare the investment, the first one is nominal rate of 10%, which is compounded semi-annually, or 11%, which is compounded once or just paid once. Which is a better investment? Now, obviously, you would have to convert that into the effective rate to make a logical choice. Okay, I think we had done this before, but we can do it again. Construct an amortization schedule for $1,000 at 10% annual rate loan with 3 equal payments. So can you do that? The first thing, obviously, what you need to do is calculate your payment. So like I said, the first thing you need to do is calculate the payment, and let me just show you. I just did that on Excel. I forgot to share it. Okay, students online, can you all view the Excel worksheet? All right, so just use this formula. Can you see the formula in the formula bar? So it's 10%, 3 payments, $1,000 to begin with. Future value should be 0, and type is 0. So we can do it again. IY 10%, number of time periods 3, present value is -1,000, future value is 0, and payment is 0. So you have to calculate the payment. So this will be PMT. Rate is 10%, number of time periods 3, present value -1,000. I'm putting negative so I can get a positive future value. Future value 0, and then type 0. So that's 402.11. So now you can start working on your amortization. This is periods. So that's the opening principal balance, which is going to be 1,000 because that's the balance on your account. You will pay a payment of 402.11, and your interest towards interest is going to be $100, and then towards principal is going to be 1,000 minus 402 minus 100. That's going to be your, okay, just towards principal is going to be this one minus this, and then your ending principal balance will be 1,000 minus 302.11. So this is going to be your opening principal balance for the next year. Again, the payment will remain the same. Towards interest now will be 10% off 697.89. So towards principal will be 332.33. Ending principal will be 365.56. That will be your opening principal balance. Something went wrong. So this is for the first year, 302.11, that's correct. Then 697 is the ending and the opening balance. So we repeat that for the second and third year. So it'll be 366 and then 402. So okay, that's going to be 402.11. Let me just share that. And then towards interest is going to be 10% of 365.56. Towards principal is going to be 365.56. Ending balance is going to be 0. So if you have 0 in the ending balance, that means your calculation is correct. So that's your basic amortization, and again, I'm going to save this and I will post it on the Blackboard page. Okay, everyone clear on this? I think I'd shown you this in the last class, but you can try it, again. So the interest declines because outstanding balance declines. So you can see that the interest is declining. More payment money is now going towards the principal pay down because the interest is declining. Because your principal balance is declining, the interest that you pay on your principal is declining. So amortization tables are widely used for home mortgages, auto loans, business loans, retirement plans, and more. They're very important. Financial calculators and spreadsheets are great for setting up amortization table, like I did that for the simple basic example. Fractional time periods. On January 1, you deposit $100 in an account that pays a nominal interest rate of 11.33463% with a daily compounding. How much will you have on October 1st or after 9 months, that is 273 days. Days are given. So again, the good thing is that a lot of information is given. All you need to do is identify the variables. In this case, what is N? 273, that's given to you. That's very good. What's going to be IY, or the interest per period? 11.33463 divided by 273. If you don't divide that by 273, that means you're paying 11.33% every single day. So effective rate is going to be what? 273 multiplied by 11.33. That's going to be like a payday loan that you're paying off. Right? That's how they are able to create that unending balance for people, is because they're charging close to what, 23, 24 effective annual interest rate. Okay, so we found two components. What is payment? Payment is 0 because no payment is being paid, right? What is the present value? It's going to be -100 because that's money going out, right? So all you need to do is just plug in these numbers and calculate your future value. So can you do that? I'll give you a minute. So it'll be 11.33463 divided by 273. Number of time periods is 273. Payment is 0. Present value is -100 and type 0. See, something's wrong. That should be a percentage here. $112. So let's see if our answer is correct. So this is just showing how to calculate it. And 273 is correct. So let me just verify what the percentage again calculation is correct or not. It's 11 point. Let me try again. 11.33463% divided by 273. So it should be 0.000415. Why is that? No, this is correct. 0.00. They take 31054. Oh, they take it a 365-day periodic rate. Okay. So this has to be divided by 365, even though that's 273, because annual, it should be divided by 365. That's my mistake. So it should be 0. Let me show it on Excel. So that's my mistake. It should be, so even though it's the annual rate 11.33463%, it has to be divided by 365 because that's going to give you your per day rate. Okay, so this is converted to per day interest. So I can delete this, and then N is 273 payment is 0. What else? Present value is -100. Future value we have to calculate. So this is going to be FV rate. Number of time periods 273. Payment is 0. And present value is -100. Type 0. 108.85. So this is now exactly as the PowerPoint. So that was my mistake. We should have taken the periodic rate on a 365-day basis. All right, everyone clear? So there you go. So this is correct. And we did the calculator solution, so we are correct. Non-matching rates and periods. What's the value at the end of year 3 of the following cash flow stream if quoted interest rate is 10% compounded semi-annually? So timeline for non-matching rate and period. You got 5% here. Non-matching rates and periods, payment occur annually, but compounding occurs each 6 months. So we cannot use normal annuity valuation technique. So what do? We can do this. First method, compound each cash flow. So this has been done exactly in a way that I showed you in the beginning. What's being done is you are now taking the number of periods. For example, if you have $100 at period 2, and then what you'll do is you'll compound for those many periods ahead. So this will be 1 period ahead, then 2 period ahead, then 3 period ahead, and then 4 period ahead. So here n is equal to 4. But this is uneven. So now you have another one which is paid at the 4th period. So in this case, you simply will have how many periods? 1 and 2. So this 4 is reflected here. Present value multiplied by 1 plus r raised to the power t. In this case, t is going to be 4. And now at this one, for this one, t is going to be 2 because there's just 2 periods of interest, which is compounding. And then finally, for the 6th is going to be simply $100 because there is no compounding happening for the 6th period. So you will just add all 3 to get your final answer of 331.80. Okay? Clear, students, online and in class? Second method is to treat as an annuity, use financial calculator. Again, what you can do is calculate the effective rate. So what is the effective rate for 10%, which is compounded semi-annually? So you can use again the effect formula, and the answer is going to be 10.25. And then now you can use 10.25 in the calculator as your IY. Number of time periods is going to be 3 because now we are not compounding semi-annually because you've already taken the effect here and converted it into annual effective rate. The payment is 100, so your future value is going to be 331.80. All right, students online, clear? So let me show you in Excel if you want to. Yeah. So look at the timeline. See what's going on. Let me clear this. So when is the first payment made? At end of the first year, right? So you will be getting an interest for this $100. Moving on. So for this $100, how many periods would you get the compounding? 1, 2, 4. So that's the 4 here, which is present value multiplied with 1 plus r raised to the power t. Same thing for the next payment that you made. That's $100. How many interest components you'll get? 1 and 2. That's 105 raised to the power t. Why is it 5%? Because it's semi-annual. 10% will be divided by 2. Or what you can do is you can calculate the effective rate for the entire year, and that will be just 1 n then, which is shown in this example by calculation of the financial calculator. So that, let me demo that. Okay, students online, can you all view the Excel worksheet? So what's happening is, it's a two-step process. The first step is converting it to effective rate. Since it's a 10% semi-annual, so to convert that into effective rate is going to be EFF. So just be effect. Nominal rate is 10%, and then 2. So the effective rate is 10.25% as indicated. This is the reason why 10.25% is being taken. Now you use this effective rate as your annual interest rate. So now you don't have to do that semi-annual, compounding transformation. So n in this case is simply going to be 3. Present value is 0 because you didn't start with contributing any funds. What you're doing is you're making a payment of $100 every 1 year, right? So the future value is going to be rate, number of time periods, payment, and then type. Present value and then the type. So it's going to be $331.80. This is what you will get at end of the 3rd year. Okay, that's why you get this number. Is everyone clear now with this explanation? I mean, why did you have to do that first of all? Why couldn't you have just taken 5% here and 10 here? I'm sorry, 6 here. Because you are making $100 contribution at an uneven time. If you had been making $100 at every 6 months, then it would have worked fine. But you're making it after an interval of 1 6 month, and that would give you a wrong answer if you used it simply by 5 and 6. So what is the present value of the stream? Again, you can do the discounting factor the same way. Comparing investments, what I'll do is I'll leave this as a homework assignment for you to work this example. And it's a work example, so you have a solution to go with in case you get stuck someplace. But I'd want you to first work out and then compare an answer. So compare that using this. So it's about a 8 to 10 slide worth of 3 comparisons. So you've got to work on three bases. One is going to be based on the greatest future wealth, which is to look at which investment gives you the better future value. The other is greater wealth today, where you may have to compare, the present value today and then the highest rate of return, effective return that you're getting for each of the investments. Okay, students online, everyone clear on this? All right, are there any questions at this point? Half the students in class are ready to go to sleep. The what? Type 0 and type 1 reflect, when the interest is paid, at the beginning of the period or at the end of the period. The payment was made uneven because if you look at the timeline, you will still take 0 because you are still making at the beginning of the time period. Time period has started, but when are you making the contribution? Yeah, so this is the beginning and this is the end. So you're making contribution at the end of the time period, right? So this example started from time 0. So this is time 1, time 2. Time 2 means end of first year. Okay. All right, Chandra, do you have a question there? You said yes. Chandra, do you have anyone has any questions? No? All right, so what I'll do is I'll let you go back to your exam if you have to finish your exam or to finish your assignments or to complete any of the pending items. I will give you until tomorrow to complete any pending work. You already finished? That's good. You're a hard-working student. You'll get full points. Those of you who are going to submit late will be given, partial credit. Because I see that a lot of students may have received their textbooks late and all that stuff. So that's okay, because this time I've been exceptionally good about providing extra days. Otherwise, I normally don't give extra days. So next semester, if you're taking my class, then you got to order the textbook and get it before the first day. So look at the timeline. Start the timeline. Start ordering the textbook in November or December. All right. Any questions, students online? No? Okay. So, today I wanted to meet and complete this chapter because we had missed a lecture last week. I wanted to, make up for that lecture and also not fall behind. I want to complete at least 9 chapters in this semester. So we'll complete another 5 chapters in this semester. That's normally, how much we are able to do. So if you have any pending assignments, if you have any case study, discussion post and all that, feel free to complete that. I will give you until tomorrow afternoon to complete your missing assignment. Yeah, 4th, yes. I'll be posting assignment, for the 4th. But it won't be counted in the midterm. It'll be counted because we won't have enough time to complete the 4th chapter. But there will be assignments related to the 4th chapter. It's one of the most important chapters, so there will be assignments. Okay, if there are no other questions, then that's all for the class this evening. And I'll see you next week with chapter 5. And hopefully, you'll also have your midterm grades. All right, thank you so much, and I'm signing